I am Dr. D. Lakshmi, Professor, Department of EEE, Amit Deemed to be University. Today I am going to discuss about load frequency control in power system. So before we go to load frequency control in power system, the main aim of a system is to give power to the consumers in a good quality. So what are the good quality to be considered are, it has to maintain a constant voltage, it has to maintain a constant frequency, and also the power should be always reliable to the consumer. So the maintenance of voltage and frequency is to be taken care in a serious way. If it is not maintained at a constant value, it will affect the appliances which we are connecting to the system, to the power system. So the main role of a power system is to maintain constant voltage, frequency and reliable to the consumers. If the frequency is not controlled, is not maintained at a constant value, the turbine blades will be affected and also the whole system lockout may occur. In order to maintain the system stability, we go for load frequency control. So at present we are using vertical integrated power system. So vertical integrated power system is nothing but the flow is a monoprice system. That is the energy flow and the money flow is in a one way. So the power flow is from generation point to the consumer with help of the transmission and distribution system. So within this monoprice system, the money from the consumer is taken by the generating station in a single way. Because of the advancements in the industry, the power demand is going on increasing. So it cannot be handled by a single generation system. We are going towards a deregulation of power system. That is, the monoprice system, vertical integrated power system, generation, transmission, distribution, and finally the end consumer are being split into GenCos, TransCos, DISCos, and the end consumer. So the main advantage in the vertical integrated power system is, as it is a monoprice system, the system stability will be maintained, which cannot be done easily in the deregulated power system. As the system is split, it is deregulated or restructured. The generation system, transmission system, and the distribution system. So the entire network putting together under one control is a tedious task. So it faces some challenges. Even though it faces some challenges, it gives some opportunities. That is, the generating companies can come. So the renewable energy resources can come into picture. So that way we can satisfy n number of loads. Not only depending upon the conventional resources, we can also use the renewable energy resources. So by considering this into effect, we are making the market as a competitive market. So by creating a competition among the market, new technologies can be used. So because of the new technologies, we can produce the power as the demand required. And the consumer not only communicates with the generation company, they can also discuss with the transmission company and the distribution company. So end consumer, as a consumer, I myself can communicate with any generating company who is giving the power bits at a lower cost. So this type of communication will be created in the deregulated power system. So because of this, there exists a problem called the security problem and the stability problem. To overcome all these things, we go for a system called as independent system operator. So the independent system operator will be taking care of all these problems. So it will be taking care of the security problem, stability problem, and also the quality of the power system. As I have already mentioned, the quality of power system is nothing but maintaining the constant frequency, maintaining the constant voltage, and also it should be reliable to the consumers. So all these things put together will be taken care by the independent system operator. So this independent system operator is having 12 ancillary services. So among these 12 ancillary services, 4 are connected to voltage regulation and 4 are connected to load frequency control. So in this topic today we shall discuss about the load frequency control. So as I already told, the frequency of the system has to be maintained constant for the dynamic change in the load. So how it will be maintained? So if you go for a vertical integrated power system, there is no problem. It is a single control, so the load frequency control can be controlled. Load frequency can be controlled easily. If we go for a restructured power system or a deregulated power system, it is a major task to maintain the frequency of the system. So for this, From this idea, we came to that what are the objectives of a low frequency control. So the objective of the low frequency control is there are two objectives. The first thing is it has to maintain the frequency of the system which is connected, and then the next thing is it has to maintain the system silent power flow between the area which is connected. So these are the two major objectives of the low frequency control. So here we will be considering three types of control in the low frequency: primary level of control, secondary level of control, and tertiary level of control. So in all these control, the primary level of control is nothing but it will be consisting of speed governing mechanism and the speed changer and finally the system. In the tertiary level of control, we will be having the PI controller. Under that PI controller, we can use any computational algorithm to control or to tune the PI controller, and finally the economic dispatch is a tertiary level of control. So with the help of all these controls, we can maintain a constant frequency of the system. So if you go for a renewable energy system, we are going for deregulation power system, is as the system is deregulated, it has been restructured. So in a generating in GenCos, we will be having several number of generating companies. So it may be a thermal, it may be a hydro, it may be a PV system, or it may be a wind system. So all these systems are considered as a single area, and these areas are interconnected with the help of a line called as interconnector called as tie line. So the low frequency control, it has to maintain the frequency control of that particular area and also the tie line power flow of the nearby area. So all these aspects will be taken care by the low frequency control of the system. So with this, we can maintain a constant frequency to the system. So by making this low frequency control, we can regulate the frequency of the power system as a constant value and make the system as a stable. We can also maintain the security of the system. So by this, we can maintain the entire deregulated power system. As we talk about the vertical integrated power system, the deregulated power system can also be maintained as a constant power supply system. So in this session, we have discussed about the low frequency control of a deregulated power system. Thank you.